Good day everyone, I'm Alan.
And I'm Jimboy.
Today, I would like to talk about organic reaction. So partner, what is organic reaction?
So, organic reactions. Organic reactions are chemical involving organic compound. The basic organic chemistry reaction types are addition reaction, elimination reaction, and substitution reaction.
So, here in the organic reaction, there's a three type of reaction. First, the addition. Second, the elimination. And the third one is substitution reaction. So partner, what is addition reaction?
So, in addition reaction, the components A and B are added to the carbon-to-carbon multiple bond. So, we have here an addition reaction examples. So, here, we have an ethylene added by the hydrogen chloride, and we have a reactants, platinum, and then we have their predicting products. We call it ethyl chloride. Alkene and alkyne reacts by addition reaction. We have here an example, ethylene added to hydrogen chloride, and we have a reactants of platinum. And we have a product, ethyl chloride. So, how we can get this?
How we can get this? So, when we see the addition reaction, we have our breaking of pi bonds and forming of 2 sigma bond. So here, there is have a breaking of pi bond there. And CH2 break the pi bond, so we have our single bond. So CH2. Then, a pi bond break will become the sigma bond. Then, the hydrogen will go here, and the chlorine go here. So, our product is CH3, CH2, and chlorine goes here. We have our product, ethyl chloride. Finally, partner, we get the reaction mechanism of addition. For substitution, partner, what is substitution reaction?
In a substitution reaction, one atom or group of atoms is substituted by another atom or group of atoms to form a new substance. We have here a substitution reaction examples. We have an ethane added to chloride, and we have the reactants ultraviolet rays. The product is ethyl chloride plus hydrogen chloride. So how we can get this?
Thanks, partner. So you're asking how to get the product of substitution reaction. By the help also of reaction mechanism. We have a 3 classification to how to get the product. First, the initiation. Number 2 is propagation. And third is termination. In part of initiation, in this part, this is an CH3. So we need to get a 1 hydrogen here. So in this part, you see the hydrogen, we get it in the CH3, so it will become CH2. And the hydrogen we get is become here. Then the symmetric chloride, we need to get this one to put it here, or to connect or to attack the hydrogen here. Then the another chlorines go to on this part ethyl. So our product is CH3, CH2, Cl, and plus HCl. The second process is propagation. When you see we get an hydrogen, we call it propagation when hydrogen goes to position here and the chlorine attacks the hydrogen. That's we call the propagation. And next, the termination is where overall we get the main product When we put it all together, that's we call termination. The third part is termination. The termination is overall. So overall, when we get the main product, that's we call our termination. Okay, now partner, reaction mechanism help us to get the product of substitution reaction. Our last part is elimination reaction. Partner, what is an elimination reaction?
So, elimination reaction. There are some reaction which involves the elimination or removal of the adjacent atoms. After this, multiple bonds are formed and there is a release of small molecules as products. One of the example of elimination reaction is the conversion of ethyl chloride to ethylene. And how we can get this?
Elimination reaction is very different in addition reaction, because in addition reaction, we're breaking the pi bond and form the 2 sigma bond. But here in elimination reaction, we're breaking the 2 sigma bond and form another pi bond. So here, we need to see the product. We have here a pi bond here. So in reaction mechanism, how we can get that? So in this part, CH2 single bond CH2. This one is then hydrogen and chlorine. So in elimination, we need to eliminate the molecules or the 2 parts of molecules, the hydrogen and the chlorine. So this sigma bond will form here to go there, then make an pi bond. So and in this one, it will become the. But wait, our main topic for today is all about oxidation. Oxidation and reaction and reduction. That meaning oxidation lose, reduction is gain. That's our main topic for today. Now, in oxidation and reduction, or the redox reaction, we have a 3 classification of alcohol. The primary alcohol and the secondary alcohol and the tertiary alcohol. So first alcohol is
So guys, primary alcohol can be oxidized to either aldehydes or carboxylic acids, depending on the reaction's condition. In the case of the information of carboxylic acids, the alcohol is first oxidized to an aldehyde, which is then oxidized further to the acid.
For more further explanation, for the first primary alcohol, this this product is an ethanol. So when we oxidize it, will become CH3, C double bond O and H. This kind is an aldehydes, and when you oxidize again the aldehydes, you can get the CH3COH, that is an carboxylic acid. In this part, these two have a fast reaction. That's only my explanation. The secondary alcohol, when the secondary alcohol goes to oxidation, our predict product is ketone. So how we can get the ketone, or how the furthermore explanation by my partner Jimboy.
So for the furthermore explanation, we have here a secondary alcohol, and we call it propanol. So, if the two propanol hit with sodium dichromate, we will form a ketone, and we call it 2-propanol.
Yes. In this part, in our tertiary alcohol, you see that there's no product, whatever you do, because if you see in our primary and the secondary oxidation, and there's no more hydrogen attached the carbon atom. So look, in the finally we're done with the oxidation, but we call it reduction. So we have our reduction. Reduction means gain. So the sign of reduction is just like this. Okay. Red. This part is red. So just think that our carboxylic acid is the given. So where reduction goes, our predicting product for the reduction is become an alcohol. So we use the reduction to English. Carboxylic acid. There's no more hydrogen, and the propanol, there's no more hydrogen attached in the carbon atom. So whatever you do, there's no product in tertiary alcohol when you oxidize it. And that's it. Thank you guys. Finally, we're done with the oxidation. But we call it reduction. So we have our reduction. Reduction means gain. So the sign of reduction is just like this. Okay. Red. This part is red. So just think that our carboxylic acid is the given. So where reduction goes, our predicting product for the reduction is become an alcohol. So we use the reduction to in this part, we use the reduction this is a minus sign, sorry. We use the reduction to return the carboxylic acid to become an alcohol again. And for the ketone, we use also the reduction so that the 2-propanol to return the 2-propanol. And that's all for the reduction. And so again, good day everyone. I'm Mr. Alan Ferrer.
And I'm Jimboy C. Kiabiab.
And thanks for watching and listening with our lecture about organic reaction. Thank you.
So guys, thank you.